Have you ever stopped and wondered, how does the internet actually move information? Like, how does a YouTube video, a message, or even this very voice reach you in seconds from thousands of miles away? Before we go deeper, here's a quick question. If the internet stopped working for 24 hours worldwide, what do you think would happen? Comment your answer. You'll be shocked by the real impact. Now, let's dive into one of the most invisible and mind-blowing systems humanity has ever created: the global internet. Most people think the internet is wireless. Wi-Fi, Bluetooth, 5G. It all feels like the world is floating in invisible signals. But here's the truth. More than 95% of all global internet traffic travels through physical cables. Not satellites, not Wi-Fi. Actual glass wires under the ground and deep beneath the oceans. These cables, thinner than a garden hose, carry trillions of messages every day. Everything you do online starts with a simple step. Your device turns information into tiny digital messages called packets, and every packet begins a long, high-speed journey. Imagine you press play on a YouTube video. Instantly, your phone says, "Hey router, I need this video." Your router sends that message through a cable to a local server, then to a bigger one, then to your internet provider's main network. Think of it like sending a letter that gets passed from small post offices to bigger ones. Each message is chopped into small packets, labeled with the destination, launched at nearly the speed of light inside fiber-optic cables. These packets travel as pulses of laser light, blinking millions of times per second. This alone is incredible. You're literally watching light carry videos, messages, and memes across the planet. But the real magic happens when packets leave your country. Under the ocean, far below where sunlight reaches, lies a network of over 800,000 kilometers of fiber-optic cables. That's enough to circle Earth 20 times. Engineers bury them, protect them with steel armor, and lay them across entire oceans. Sharks used to bite them. Yes, that actually happened. So now they're reinforced. Most people imagine satellites doing the heavy lifting. But satellites are actually slow. Fiber cables are faster, safer, higher bandwidth, and cheaper to maintain. When you stream a video from another continent, it travels through these underwater cables in less than a second. One blink, that's all it takes. If you could see the internet as a world map, it would look like a glowing spiderweb of light. Each country connects to several landing stations. These connect to data centers. Those data centers connect to cloud servers. And everything loops back into the Undersea network. It's not one big internet. It's thousands of interconnected networks agreeing to share data. That's why it's called the Internet. Interconnected networks. The Internet is basically the world's most cooperative library, run by different companies, governments, and technologies, all speaking the same language. Inside fiber cables, light travels very fast, but not exactly at the speed of light. Inside glass, it slows down to about 200,000 kilometers per second. Still crazy fast. But on its journey, every packet must hop between routers, pass through servers, get checked for errors, get reassembled, and find the fastest path. Sometimes packets take different routes and arrive slightly out of order. Your device calmly rebuilds them into the original message, video, or image almost instantly. This multitasking happens billions of times per second across the world. Now imagine the packet reaches its destination server, maybe a YouTube server. The server checks, Is this a valid request? Which video quality does the user need? Where's the nearest data center to reduce lag? Then the server sends millions of tiny packets back to you. This is why big tech companies build data centers everywhere, to shorten the distance and reduce delay. A request in Nigeria shouldn't wait for a server in California. A request in India shouldn't depend on Europe. The closer the server, the faster the video loads. When the video starts playing, data packets rush back through. Data centers, undersea cables, local networks, your router, your phone. Everything working in perfect harmony. So the next time a video loads instantly, you're really watching a high-speed global light show happening beneath oceans and across continents. The internet feels magical, but behind the scenes, it's one of the most advanced engineering systems ever built. Tiny packets of light traveling through glass cables, powered by data centers the size of football fields. All so you can watch a video, send a message, or learn something new. If you want more deep, simple explanations of the hidden systems that run our world, hit subscribe, because we break them down one by one.